To solve this quadratic equation by completing the square, we need to create a perfect square trinomial over here on the left-hand side. A quick example of a perfect square trinomial is x squared plus 8x plus 16, and this is a perfect square trinomial because it factors into the same binomial times itself, which would be in this case x plus 4 times x plus 4 or x plus 4 quantity squared. It needs to factor into a binomial times itself. So let's give ourselves a little bit of space for a number that is going to complete the square on the left-hand side. We want to figure out who is this value that needs to be added into the left-hand side so that the left quadratic is a perfect square trinomial. Let's refer to this number that we're looking for as the magic number. And the way that we find this magic number that completes the square on the left-hand side is we use the formula b divided by 2 and then we square that quantity. Well, the b term is in this case -5. So we're looking at -5 divided by 2 and then we square that quantity, which gives us -5 squared in the top is 25, and then we square the bottom as well to get 4. So the magic number that we're going to be adding into the left-hand side in order to complete the square is 25 over 4. But we have to add that to both sides of the equation in order to preserve the balance. So let's hop down here and say, how does this left-hand side now factor? It needs to factor into a binomial times itself, the same binomial multiplied by itself. In order to complete the square, we needed to have a leading coefficient of +1, and when we factor a trinomial where the leading coefficient is +1, we know that we get an x in the first position of these binomials down here. Since the binomials are the same, we know that we're going to have the same sign in each of these. That's also supported by the fact that this is a plus right here, which means the signs inside the binomial have to be the same. But then we look over here to see what they are. They're the same and negative, so I'm going to have 2 negatives inside here. Factoring with fractions is definitely tougher, but a perfect square trinomial is going to factor according to a pattern. The number in here, of course, has to be the same. This is the same binomial times itself, and the value that goes in the factorization is sitting right here, actually. It's the square root of that magic number that we had. It's the value that we obtained when we originally divided the b by 2 before we squared it. So 5/2 is the number that goes in here and in here, and we can always easily find it in the step we used to find the magic number in the first place. Now we need to add these two terms together here on the right-hand side, which means we need a common denominator, and the denominator is going to be 4, so I'm going to multiply this number by 4 over 4, which gives me -16 over 4 plus 25 over 4. So on the left-hand side, let's now call this x minus 5/2 quantity squared, and on the right-hand side, when we add those two things together, we get 9/4. And now we're at a place where we can apply the square root method. We can take the square root of both sides of this equation. And when we take the square root of both sides, we have to consider the plus or minus possibilities. So the square root of x minus 5/2 quantity squared on the left, the radical and the square are going to cancel each other out, and we'll be left with x minus 5/2. On the right-hand side, remember, we can split a radical over division, so this becomes the square root of 9 over the square root of 4, and of course we still have the plus minus, so this is plus or minus, the square root of 9 is 3, the square root of 4 is 2. Now, because we have a plus and a minus here, we actually want to then split this up into 2 separate equations, one of which is x minus 5/2 is equal to the positive 3/2, and the other x minus 5/2 is equal to the negative 3/2. So this gets split up into 2 separate equations, which makes them easier to solve individually. Now, we'll add 5/2 to both sides in both of these equations to get x is equal to 3/2 plus 5/2 is 8/2, which is 4. And over here we have x is equal to -3/2 plus 5/2 is 2/2, which is 1. So the two solutions here are going to be x is equal to 4 or x is equal to 1.